For question number 5, a parachutist falls from a stationary balloon at time t is equal to 0. The velocity time graph for the parachutist from time t is equal to 0 until the time when he is above the ground is shown. So this is the velocity against time graph, which graph base shows the variation with time of the acceleration of the parachutist. So which graph is the variation of time with acceleration? Now this is a velocity time graph. So what would be the acceleration time graph? So in general, for a velocity time graph, the gradient of the velocity time graph is acceleration and the gradient of the velocity time graph is displacement. So the gradient of the velocity time graph is acceleration. That is, gradient is equal to acceleration. So, and what is the gradient? So the gradient for a horizontal line is 0 and the gradient for a vertical line is infinity. So as we move from 0 to infinity, here we can see that the gradient increases. That means as the line becomes more steep, the gradient increases. So if you compare these 2 points, then the gradient at this point is approximately this line and the gradient at this point is approximately this line. So here we can see that the gradient decreases because the line becomes less steep. So the gradient decreases. So the gradient decreases, and in general, since the gradient decreases, so the acceleration must decrease. So acceleration decreases and acceleration decreases. Now here we can see that acceleration increases from a negative value to 0, and this would be wrong because the acceleration must decrease. So acceleration must decrease, and this is a positive gradient. So if we indicate the direction of the gradient, then the direction is like this. So the gradient is positive. So the acceleration must be positive. And here we can see the acceleration is negative. So these two are wrong. Now, for a horizontal line, we know that for a horizontal line, the gradient is 0. And since the gradient is 0, so acceleration is 0. As gradient is 0, so acceleration is 0. So 0 acceleration and 0 acceleration. It is also 0 acceleration and 0 acceleration. Now, for this region, if we draw the gradient at this point and at this point, then this is approximately this line and this is this line. So here we can see that it is pointing towards the negative direction. So, or in general, here we can see that the gradient decreases and the gradient decreases and the gradient is negative, because if we indicate the direction, then the direction is negative. Since the direction is negative, so the acceleration should be negative and acceleration decreases. So from point Q to R, that is Q to R, the acceleration is negative and the acceleration decreases. So here we can see that the acceleration in general decreases and the acceleration is negative. So acceleration is negative and the acceleration decreases. Now, here we can see that for this region, the gradient is less steep, and for this region, the gradient is more steep. Since the gradient is more steep for this region, so the gradient is more. Since the gradient is more, so the acceleration value have to be more. So for this region here, we can say the gradient is less steep, and for this region, the gradient is more steep. Since the gradient is more steep, so the acceleration is more. So the acceleration is higher at this point. Acceleration is higher, and acceleration should have a negative value since the gradient is negative. So the acceleration should have a higher value. There is a higher value, and the acceleration should be negative. So here the acceleration is negative and acceleration must have a higher value compared to this region. So compared to this region, the acceleration must have a higher value and the acceleration should decrease from a negative value. So the answer should be B. Then here we can see that for a horizontal line, the gradient is 0, so acceleration is 0. So the correct answer would be B. And again, if we see this region, then this region, for this region, the gradient decreases and the gradient is more steep compared to this region. Since the gradient is more steep at this region, so the acceleration would be more. Since the gradient is more, so gradient is more, that is gradient is more, so acceleration is more, and since the gradient is negative, so acceleration must have a negative value, and so it is not A, it is B, because the acceleration is more at this point. So the acceleration is more and the acceleration is negative since the gradient is negative. So the correct answer would be B.